I'll get the rest of this unrecorded and I'll record the other piece. My bad. I'm new at this. All right. So here's the number 4, okay, which is the using Descartes' rule of signs. It's something we left off on when it comes to finding our roots and making figure out how many possible roots we can have. So to find the positive roots, remember we made that little chart. So we had positive, negative, and then imaginaries. Okay, well, how many roots does this have? This is going to have 7 roots. Okay, because the total degree is 7. Making sure I catch them all, put them all equal to or in order so I can see them. Okay, and then to find the positives, we're going to count our sign changes. So there's a sign change, that's 1, 2, 3, 4, 5, and 6. So there are 6 sign changes, which means there is a possible of 6. And then remember when we talked about this before spring break, you always subtract 2 from that. So that would be possible 6, 4, 2, or 0. Okay. All right, so then we got to figure out, well, what would be our possibilities in terms of negatives? So remember, what I have to do is find k of negative x, which means we're going to plug negative x in here, which means anything with an odd exponent would change signs. So this would become positive, that'll stay, that'll stay, that'll become negative, that'll stay, that'll become negative and negative. And notice right here, there's only one sign change. So that means there has to be 1, and all of these would actually end up being 1 at that point, because that means there has to be 1 negative root inside this problem. And now remember, since it's a total of 7, I add these up. That's 0, that's 5, that means 2, that's 0 imaginary, 2 imaginaries, maybe 4 imaginaries, and then, oops, that came right, 6. Okay, and remember, imaginaries always work in pairs, so that number always has to be an even or 0, one of the two. Okay, so that's using Descartes. Okay, and I will tell you there's a Descartes question on the test. All right, so let me do one more, then I'll unmute for any kind of questions that might be out there. Okay, nobody else has gotten in yet. So, all right, so here is a vertex form for you actually to look at. Okay, remember, HK is my vertex, so my vertex would be at 1, 1, opens, down. And when we talk about a sketch, since there's no graphing on the test, you're just going to get asked questions off certain type of things. There's your 1, 1, okay? If you wanted to find a y-intercept, okay, the y-intercept, if I put 0 here, that'll give me a -1, which is 1. 1 times a negative a third would be a -3rd, plus 1 would be a 2/3. So really, you're going to have graphs here and here. Okay, and that's probably enough to actually even just sketch. So it's going to look something like that. Okay. If I wanted to find these x-intercepts, to actually find where they're at, probably going to be kind of nasty. I'd put 0 in for q of x, and you'd actually have to solve for x. Okay, I should get 2 answers. That's going to come from the square root. Okay, so it's going to be -1. Forgot I had a negative in there. Multiply both sides by positive or -3. That'll give me a 3. And then square root both sides, and that's where the plus or minus comes in. And so my x-intercepts are going to be at 1 plus or minus the square root of 3. That would be my x-intercepts for that, which you wouldn't be able to graph it anyway because it is irrational. Okay. All right, so I'm going to unmute y'all for a second. Any questions that I've covered so far?
Yeah.
Uh-huh.
For the Descartes rule thing, how did you get the number for the negatives?
What you have to do is you're going to sub in negative x into all the x's. And what we learned right before spring break is anything with a negative, or excuse me, anything with an odd index or degree, an odd exponent is going to change signs. So this is an odd exponent, so that's going to change signs to plus. Even's going to stay the same. Even's going to stay the same. Odd changes signs. Even stays the same. Odd changes, and the constant always stays the same. And then you count your change of signs again, which is just 1.
Okay.
And if you get an answer of 1, either for plus or positive or negatives, that means it has to have 1 no matter what. So all across the board, you'd use a 1.
Okay.
All right, that makes sense?
Mm-hmm. Yeah.
Any other
Thank
questions?
you.
You're welcome. Everybody else okay? All right, I'm going to mute y'all back. And we're going to hit number 6. Again, number 6 here is a multiple step question, but there is no multiple step questions on the test. It's just going to be one answer or another. Now, I will tell you this. There are a couple multiple choice questions that have like 7, 8 possibilities. So choices for you to choose to. So didn't kind of make it the best out of 3 or the best out of 4 for some questions. So just be aware of that. Don't freak out when you see it. All right, so let's look at this next problem. Okay, it's just a long polynomial. Happens to be in order already, so we're good to go. Okay, so what we're going to do is just answer these questions individually. What is the total number of roots or zeros in this polynomial? Remember, we look for the degree. And this is degree 5, so there are 5 roots. All right, so this is another practice of Descartes' rule. Okay, so, and we use this to help us figure out some of these possibilities because this one does take us a little bit more work that we got to deal with. Okay, so determine the number of possible positive and negative zeros. So the positive, okay, I'm going to count my sign changes again. No, yes, there's 1, no, 2, so there's just 2. So this one has the possibility for positive of 2 and 0. We'll just put it here, 2 and 0. And then negative, okay, we're going to plug in and only change signs that are odd exponents. So this one would change. This one stays the same. This would change. This one stays the same. That one changes, and that one stays the same. Count our possibilities here. 1, 2, and 3. So for negative, we're going to have, we'll just put it here again, 3 or 1, okay? Which means, and it doesn't ask for imaginary, but imaginary, you're either going to have 0 or 4. Yes.
Okay. I don't understand what you're doing for B.
Okay. Remember, we're counting sign changes. Okay.
Yeah.
So, positive ones, you just count the sign change from the original polynomial. So wherever it changes signs, positive to negative. So that's positive, positive. That's not 1. Okay. Okay. And then positive to negative, that's 1. Negative to negative is not 1. Negative to positive is another one, so that's 2. So that's 2 sign changes. So remember, you always start with 2 and then minus 2. And then when you do the negative one, you only change the signs to the ones that are odd. So that one changes, that one doesn't. This one changes. That one doesn't. This one changes. And now you count sign changes again, which happens to be 1, 2, and 3. So that's where you get the 3 and the 1. All right?
Oh, okay. Yeah.
Better? All right. So let's list possible rational zeros. Okay? Now, this is the plus or minus problem that we did. Okay? In which you're going to take the constant, which is back here. You're going to find the factors of the constant. Let's do this over here. So we're going to have the factors of 20 over the factors of the lead coefficient, which is just 1. Okay? So what are the factors of 20? 1 and 20, 2 and 10, 4 and 5. And then all of those are over 1. So we go plus or minus those. So those are my possible factors. Now, per se, if there was a number out in front of the x to the 5th, I'd have to find the factors of those besides 1. And then each of those factors has to go under the factors of 20. Okay? So if you were given something like, let's just say, what if, so you know, anybody who jumps in, what if h of x was 6x to the 5th plus blah, 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 plus 8. All right, the possible factors would be the factors of 8, 1, 2, 4, and 8. And then if I take the factors of 6, 1, 2, 3, and 6, you'd have to take all of those over each of these. These are all over 1. Then you would do all over 2. And then all over 3. And then all over 6. Okay. Now at that point, you can get rid of all the repeats. Okay, and there's some repeats in there. Okay, so here's a repeat. There's a repeat. There's a repeat. Okay, let's see. No repeats there. There's a repeat. There's a repeat. And there's a repeat. And then you would put plus or minus in front of all of those. So that's if there's a number out in front. I didn't want to give you one of those for this problem because I didn't want to have to plug in any fractions. Okay. All right. So let's go back to this problem. Okay. So these are my possible factors. Okay. Mimi, do you have a question or are you good?
I do have a question, but
What?
I feel like you're far off, so I don't want to.
Okay. We'll catch it a little bit then. All right. So it says use 6a with synthetic division. So basically this is this problem. I don't know why there's the a there. But we're going to use synthetic division to find the zeros. So remember, here we have our problem. Okay, so we're going to go with synthetic. So this would be 1, 5, negative 5. Was it negative 25, 4, and 20. Bring that one down. And we're going to see if we can find one that will give me a 0. Okay, so we're going to start plugging in these numbers. Start with the easy ones. Okay, now just so we don't waste a lot of time, I'm going to tell you 1's actually going to work. So we're going to run 1 through. This will be a 1. This will be a 6. Okay, that'll be a 6. That'll be a 1. That'll be a 1. This would be a negative 24. This would be negative 24, negative 20, negative 20, and 0. Okay, so 1 is a 0. So that's one of my factors, x minus 1. Okay, Now, you would have to do this again one more time, because that's 5. I want to get this down to 4. Okay, so we would actually check 1 again, but 1 won't work. I'm going to tell you again, you check 1, 1 doesn't work. So then check -1. Okay, now just so that we're not going to waste a lot of time, -1 should work, because I've done this before. 4, -4, that's a 4. That'd be -20, that'd be 20, and that's 0. So -1 works, so that's x plus 1. Okay, now the leftover to this, if I started at x to the 5th and I've got 2 zeros already, that means I'm down to x cubed. So I need to do this one more time. Okay, so I would actually check -1 again, but -1 won't work. Okay, a second time. So then I'd go into, since I know my answer is 2, so I'm going to do this one more time. Put a 1 here, that's going to be a 2. That's going to be a 7. That's going to be a 14, 10, 20, and 0, which means 2 works. So 1, -1, and 2. Okay, now this gives me my compressed equation. X squared plus 7x plus 10. And that actually now can factor to x plus 5x plus 2, which gives me my other 2 factors, x plus 2 and x plus 5, and my zeros of -2 and -5. Okay, so I found all 5 factors and all 5 zeros, which these are all single roots. None of them are the same. They all have either sign differences, which means they're all single roots. Okay, so when I look at that, it says, now find the y-intercept. The y-intercept, remember, is always my y, the constant. So it's at 0, 20. And the in behavior, to sketch this, remember in behavior, if it's odd and positive, the in behavior is going to be starts low, ends high. So low to high. Okay, if it was even positive, it's high, high. Okay, so if we want to show that real quick, so just so you have it, if you forgot it, in behavior, remember if it's positive and even degree, it's high, high. If it's negative with an even degree, it's low, low. If it's positive with an odd, like the one we just did, low to high. Whoops, sorry. And if it's negative with an odd, it starts high and ends low. Okay, so just a little extra for your notes right there. If you forgot, that was stuff we did before spring break. Okay, now if I was to sketch this, which is it's actually asking me to sketch it, okay, you would have to do the following. We have roots at 1, -1, 2, and -2, and then out here at -5. And then way up here at 20 is my y-intercept. So starting low, and since they're all single roots, they're going to go through, come back around, come back around. It's got to go all the way up here, come back around, and you get something that looks like that. Again, there's no graphing per se on the test, but being able to recognize something will be helpful. All right, so let me finish off this second page, and then I'll take whatever questions you might have at that point. Okay, and then we'll get to the last page. It says write a polynomial form in lowest degree. All right, so to do that, And we're not going to be real picky in terms of A's and putting the A's out in front, but just being able to recognize. So if I have a 0 of 1, that's going to give me x minus 1. I have a 0 at negative 1, but it's at multiplicity of 2. So I give it a square. Okay? Then it tells me I have a multiplicity, or then I have a 3i. So that means I'm going to have x minus 3i, but you need to remember these always work in pairs. So if I have an x minus 3i, I have to have an x plus 3i. Okay? So because they work in pairs, you got to have that piece there too. Okay? Now, in lowest degrees just means let's go ahead and multiply this out. I would be smart about this and just go ahead and multiply those two first, because since they're conjugates, it's going to be x squared, and that's going to be 9i squared, which gives me plus 9. Okay? Now here's where it gets a little, I don't know which way you'd like to go with this. You can do the shortcut to this one, and then multiply this out together. Okay? So I'm nothing this long on your test, just because this would take you too long, you'd run out of time. But if you can multiply this, you'd be able to multiply anything that we give you on the test itself. Okay? Let's just go this way. We'll just multiply the x. So that's going to be x cubed plus 2x squared plus x minus x squared minus 2x minus 1. Let's simplify that. X cubed plus x squared minus x minus 1. Hope that's right. And now we're going to multiply x squared plus 9 to that. So that'll give me x to the 5th plus x to the 4th minus x cubed minus x squared. Now it's in the 9 through. 9x cubed plus 9x squared minus 9x minus 9. And then put everything together. X to the 5th plus x to the 4th plus 8x cubed plus 8x squared minus 9x minus 9. And that is my f of x. Now notice, what is my degree? My degree ended up being 5. If you go back here, there's 1, which is a single root, that's 1. A double root counts as 2, so there's 3. And whenever you see an I, you got to count it as 2. So 2, 4, 5 would give me the degree of 5. And that'll save you some time on certain questions. Okay? All right, so that's through page 2 real quick. Okay? Any questions on I'm going to unmute you if you want to be unmuted for a second. Okay? Anybody have a question on anything on the second page that I can go over with you real quick?
I have a question.
Yes.
When you're doing synthetic division,
Yes.
why again do you have to, for part number 6, why
Yes.
again do you have to check number 1 and then -1 again a second
Okay,
time?
so remember, if it's a double root, it would work twice. And the only way you can figure out if it's a double root or not is checking again. Once you, like here, if you check 1 and then you check 1 again on this second row, it won't work. At that point, you now know 1's a single root. Okay? The bad thing is, on a really long problem sometimes, if you check 1, you do 1, it works, and then you do 1 again and it works, you'd actually have to check it a third time to see if it's a triple root. But once it doesn't work, it won't work again. Does that answer your question?
Yes, thank you.
You're welcome. Anything else? Everybody's good? Cool.
Yeah.
So let's get to the last page. All right, one of these days I'm going to retype some of this up, but all right, it says sketch the polynomial that is in already in factored form. Okay, so things that we want to be able to do. zeros and their multiplicities. Okay? So if we can find the zeros and the multiplicities, it's going to help us sketch over here. Okay? So notice this x squared. Do not forget about the x squared. This one would give me a 0 with a multiplicity of 2. This one gives me a 5, which is a single root. -4, which is also a multiplicity of 2. And then 2, which is a single. All right, so to do that, okay, as we look at that, we're going to plot all those. So we're going to have a double root here at 0. 1, 2, 3, 4, 5. -4 with a double root, and 2 with another root. Okay, now the next thing we need in behavior. So I need to know its degree. So that's a 2, 3, 4, 5, 6. So this is going to be degree 6, which is even. So since that's even, and this is positive out front, this is going to have a high to high arrow. So it's going to go high to high. Okay. Now the only other thing I think you would actually need would also be a y-intercept, but this one's actually pretty easy because the y-intercept would have to be 0 because I already have a 0 root. So the y-intercept would be 0, 0. How would I find the y-intercept otherwise? Put 0 in for all the x's. But once you put 0 here, 0 here, 0 here, and 0 here, this 0 multiplied to all of this makes it 0. All right, so now the rest is just connecting them. Now remember, the double roots are here and here. Everything else is single. So when I get to the double root, we bounce. Then we go to this double root, we bounce. And then we're going to go through these guys here and here. Okay, so that's why we have the bounce, and then single roots they go through. FYI, in case you needed to know, if you forgot, the triple root, okay, looks like this, right? And it goes through like a cubic function. Okay, so if you see that triple root, that counts as 3. Okay, so it didn't show you on any of the other problems, so I'll make sure you see it in case you see it on the test. All right, so number 9, okay, finding the vertical asymptote and the horizontal asymptote. Okay, we hit this right before spring break. Okay, so vertical asymptote, okay, will come from factors here. Horizontal asymptote will come from our degrees. Okay, now to do the vertical asymptote, make sure you factor everything first. So we're going to factor the top because it's not factored yet. And this would be what? X plus 5, x minus 2. All right, so when we deal with vertical asymptotes, we're going to look at the bottom. Where does my domain miss up at? So my vertical asymptotes, normally if I just look at the bottom, I would have a vertical asymptote at x is equal to 2 and x is equal to -2. Okay? However, because of this guy here, that ends up being a hole. Okay? We're not going to test you on holes, but this happened to be the problem that's in here. Any hole counteracts any vertical asymptote. So because this one's the same as this one is not a vertical asymptote. So the only vertical asymptote in this problem is here, is at x is equal to -2. Okay? So do you want that graph, Aaron?
Shouldn't it be a -3?
Which one are you talking about?
The top, the factor you circled Shouldn't that be -3?
Oh, you know what? It is. You're right. I thought that is a -3. Thank you, Aaron.
Yep.
So that does mean this one does work. My bad. Friday. Good catch. All right. So if they have been the same, then I would cancel it out. But that one's not the same. And again, I'm not dealing with holes on your test. There are no holes on your test, so you don't have to worry about the holes. Thank you, Aaron. All right. So vertical asymptotes. So there's two of them. X is equal to 2 and x is equal to -2. Make sure you write them like that. Horizontal asymptote. Remember, we look for our degrees. Now, you need to understand which ones are degrees, okay? So on the top has a degree of 2. The bottom also has a degree of 2 because that's a 1 and a 1 exponent. So if I was to multiply that out, that would be x squared. So in this case, whenever they have the same degrees, your horizontal asymptote is going to be over the lead coefficients over each other, or 1 over 1, which is 1. Okay, so that's the answer to this problem. Okay, so just in case you forgot, how do I find horizontal asymptotes? If the degrees are equal, it's x, or excuse me, y. That should be y is equal to. Y is equal to the lead coefficient over the lead coefficient. If the numerator is greater than the denominator degree, these are in your notes somewhere, you should have no horizontal asymptote. And if the numerator is less than the denominator, you're going to have y is equal to 0. Those are the three cases. Okay, horizontal should be at y is equal to. Okay, so those are your three cases. And I'll be flat out, since y'all are here, I'm gonna tell you, you're gonna have a question on trying to find the vertical asymptote, and you'll have a question that finds the horizontal asymptote. So you gotta know how to do both. Okay, now slant or oblique, that's just a different name. Some books use oblique, some use slant, so I just want to make sure you know both of them. Just find the slant or the oblique asymptote equation. Okay, this one does have a slant asymptote. Now, when does it have a slant asymptote? It's when there is no horizontal asymptote and the degrees differ by 1. That's when you have a slant asymptote. Okay, so the top degree has to be bigger than the bottom degree, which it is, and 3 is only 1 more than 2. So this has a slant asymptote. Okay, so if these do not qualify, then it does not have a slant asymptote. Okay, so you would just say no slant asymptote. Okay, so what I have to do is I have to long divide this. Okay, so we're going to go x squared plus 0x minus 7, and you can't synthetic it, unfortunately. So you have to long divide. So again, this is stuff we did. So we got to match the front term up, so that's an x. We're going to multiply x cubed plus 0x squared minus 7x. We're going to subtract, which will give me 3x squared plus 5x minus 4. And match it up one more time. That's a plus 3. It'd be 3x squared plus 0x minus 21. Subtract. And at this point, it doesn't even matter what you're going to end up with at the end here. What's my remainder? Positive 17. But that doesn't matter. It's this that is your slant asymptote. So your slant asymptote is y is equal to x plus 3. It is whatever the quotient is, not the remainder the remainder has nothing to do with it. Okay. Now notice, again, there's no rational problems in terms of graphing on the test. I don't even have it on the review. The stuff that you've had in this 3.5 section is here, knowing how to find asymptotes, okay? And that's basically the big stuff, the asymptotes and maybe a y-intercept or two, something like that, okay? But you do not have to graph anything, okay? All right, so the last two questions comes off the 3.6, okay? The stuff that I left you a note on, okay? Notice there's only two questions, only a couple things I need you to know from this, okay? They want you to find where f of x is less than 0. All right, so f of x, remember, is your y. So where are my y values less than 0? Well, that's going to be everything below the x-axis. So this answer here is going to go, this is from right here to here. So all of this part is below the x-axis, and we're going to answer it by using the x values in an interval. And the x values here are from 1 to infinity. Now, is 1 included? Well, in this case, 1 is not included because there is no line underneath of it. If it would have been f of x is less than or equal to 0, then it would have been from 1 to infinity, including the 1, because 1 would count if it's got the equal to part. Okay, so in this case here, what if it said above 0? Then it's going to be this whole thing right here. Okay, and you could write that in one interval. All right, the last part of this is figuring out number 12, which is just an inequality in which we're trying to solve for C. And what values will C be if it's greater than 0? The whole thing's on that side is greater than 0. So what we're going to do, this is already in factored form. And that's factored form is what I want it in, because what we're going to be able to do is say, okay, C here's, that C here would be 0. This C here would be at -2, happens to be a double root, but that's not going to matter too much. And this C here, to make that 0, would be a 4. And what we're going to do is plot that on a number line. So here's 0, -2, and 4. And since there's no line underneath this, all of these zeros are open. And we're going to check values here, 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 and here. Okay, so what we have to do is we have to check and plug in something like -3, -1, 1, and 5. We just got to plug those in and see what we get. Okay, so off to the side, we'll just have to do that. So I'm going to plug in -3. If I plug in -3, I'm going to get 15. -3 here would be -1 squared, which is 1. And then -3 there would be 7. Okay, so -3 would be -1, that's squared. -3, that's 15, yep. So is this going to be greater than 0? Well, those are all positive. That's going to be greater than 0, so that's going to work. So that side's going to work. 3 is going to work. -3 is going to work. Plug in -1. So -1 is going to give me 5 times 1. -1 would give me, what, 5? Is that greater than 0? Yeah, that's greater than 0. Now we're going to plug a 1 in. So we plug a 1 in, that's -5. 3 squared is 9. 1 would be 3. Is This is going to be negative, positive, positive. That's going to be a negative value. Negative's not going to be greater than 0, so that doesn't work. And then we plug the 5 in. 5 times negative 5 will be negative 25. 5 plus 2 is 7. 7 squared is 49. 5, that'll be a negative 1. Now notice, I don't care what that multiplies. I just have to know, is it bigger than 0? Negative times a negative would be positive. Is positive greater than 0? Yes. So that works, and that works. So it's everything between here, here, and here. So my answer, negative infinity to negative 2, union negative 2 to 0, union 4 to infinity. And there's my answer. All those answers would work in that problem. All right. So, okay, any questions on this third page? And I'm going to take a picture of all these and post all the answers too.
I have a question.
Yes,
For number 11,
yes.
when you're doing the interval, why don't you start at 0 since that's the point where it goes below the x-axis?
You're right. It is 0. Huh? Should be 0. I'm thinking of a different problem. It is 0 there. My bad. You are totally correct.
I have a question.
Yes.
For number 10,
Mm-hmm.
when you said that when it's a slant asymptote,
Mm-hmm.
the degree differs by 1, does it only apply if the numerator's degree is greater than the denominator's?
Yes, because it has to have no horizontal asymptote. So it actually has to fall under this category. So it can only work on that one here. That makes sense?
Mm-hmm.
Yeah, that's the caveat that has to happen. Okay, good questions. Anything else? Okay, so I will do this for you guys, so that especially those of you who don't like to ask questions on that kind of thing. If you are good, okay, you're more than welcome to leave the Zoom, okay? And if you have some extra questions you want to ask, or even if there's something else you need to ask me, just stay on. I'll mute everybody here for a second. I'll give a couple minutes for those that want to leave can leave, and then in about 2 minutes or so, I'll unmute people and I'll take more questions. Everybody good then?
Yeah.
Yeah.
All right. So if you think you're good, go ahead and log out. And if you want to stay, then just stay for a little bit and I'll unmute you all here in a second. Okay.
Thank you.
So, looks like I got 2 left.
Mhm.
Kiki and Julian.
Yeah.
All right,
Yeah.
so what kind of questions y'all got? Is it over the review?
And on number 11.
Okay. Yeah, I'm
so
probably
if
confused
it
a little
was
bit.
like x is greater than 0, how would you write that?
All right, so good question. Let's do that. Okay. So let's say f of x greater than 0. Okay, so if it's greater than 0, we're looking for everything that's above the x-axis, right?
Mm-hmm.
So if we look at that, that'll be all of this area, correct?
Yeah.
All of that. Now, the only part that's not above the x-axis is right there at where it touches the x-axis, correct?
Mm-hmm.
So if it was greater than 0, I would write negative infinity all the way to the -2, not including the -2, and then union 2 to 0. Okay. Now, the weird thing about this is if it was f of x is greater than or equal to 0, I wouldn't just lock this in. I could now say negative infinity all the way to 0, because if it's greater than or equal to 0, that -2 now is equal to 0, so that now counts. So basically, this whole graph would count. So you would just go negative infinity to 0. That makes sense?
Mm-hmm.
So,
Yeah.
That first one will be -2 to 0.
yeah, I said -2, but I wrote 2. Yep.
For number 8, how did you find the numbers? I don't understand number 8.
How do I find these?
Yeah.
These numbers? Okay. So I'm just looking, since it's in factored form already, what makes them 0?
Mm-hmm.
Okay. Well, I'll go backwards this time. What makes this one 0 is 2, correct?
Mm-hmm.
What makes x plus 4 0? -4.
-4.
And then what makes this one 0? It's 5. But then you can't forget this one. What makes x squared 0? 0. That's the tricky one. Okay. And then it's a degree of 6 because I have a degree 2. That's an exponent 2. So that's a 2, a 1, a 2, and a 1. So count all those up. That's 6.
Okay.
That helps you with your root or your degree, your zeros.
Okay, so how do you know if it's a double or a single?
Well, if it's in factored form, it's going to have a square, right?
Okay.
If it doesn't have an exponent, it's an exponent of 1. So factored form, if there's just one of them, then it's a single root. It's if there's a square or 2. If you would have found x plus 4, that's a double root.
Mm-hmm.
A triple root would be x plus 4
To
cubed.
the third? Okay.
Yeah.
That's it.
Then you'd have that picture. You
Yeah.
good?
Yeah, that's it. Thank you.
You sure? Are you
Mhm.
catching up with all that stuff for me?
Yeah, I am.
Okay. All right.
All right, thank you. Have a good day.
You too.